This conference will now be recorded.
Perfect. So I think there are a couple of good morning, everyone. Thanks for joining as always on early Friday morning for the ODSA call. This is the set of agenda which we have from our past discussions. And today, the primary plan is to have Ravi Mahajan come and talk to us about the lexicon which HIR uses for chiplet-based activities. So the primary reason we are doing this is there is a parallel effort within ODSA to converge on a common language which all of us can use as we talk to each other, so that there is no confusion or we don't have to add qualifiers, etc. And ODSA Business Workstream is working on this effort with Ali leading this along with everybody else. So the idea here was to get some view from external organizations who are already doing this kind of work, so that we don't reinvent where possible. The idea is not to reinvent, the idea is just to kind of capture everything so that we all can refer to this lexicon or a dictionary anytime there is a confusion, right? So I don't know if Ravi is going to be able to join, but in the meantime, we also have, a quick discussion on the ODSA itself. So I wanted to kind of quickly run this through in terms of all of us having opportunity to present papers, abstracts at upcoming Global Summit, which is happening in November 9th and 10th. So I went through this online setup just to see how it works, and I wanted to quickly show everyone. This is basically the link for call to papers, and when you start the submission process, you will need something called FNID. I already have an FNID, so in fact I can sign out and I can show you. So this is an ID which is basically created by FNTech, which is the organization behind doing a lot of virtual setup with OCP. So please make sure all of you have created an FNID. It's pretty simple, but you have to go and basically create one before you can do any submission. And then once you do that, you will be entering a screen for abstract submission. It's a pretty straightforward process. You just say add new presentation, and then the idea here is to pick one. Now the only comment I have, and this is something we need to take care of, and Bapi, you should take a note of it. I do not see in the general topic of presentation anything on lines of ODSA or chiplets or anything of that sort. So we are going to fix that, because if we are trying to create a track for ODSA, there should be an explicit call out, or at least there should be a category called others, and everybody can use the same nomenclature as ODSA so that we can organize a track. But other than that, you start your title, and then you go through the keynote and etc. So any questions, any comments on this first topic? We are hoping that everybody is thinking of things to submit. July 23rd is the last date, so please make sure that you do that. And we also will plan to have a panel. So I think all of us who are thinking of panel should be also submitting panel entries with a short description of what the panel is going to be about, what kind of problems it's going to talk about, etc. We are creating our internal deadline as 7/16, and I think anybody who needs help while you're submitting this, please reach out to Bapi, myself, or you can present it here as well, what help you need. So with that, I think, are there any questions on what we are heading towards for the Global Summit between now and 16th of July, which is not too far away? Can everyone hear me? Is everyone asleep?
Yeah, we can hear.
Yeah, we can hear.
Is this available? This note, meeting minute or note?
Yes, yes, this note is always available. This is an open document. I am going to share it in chat right now for everyone to have access. There you go. Everyone should have access to it.
Okay.
And I'm going to share this link as well, and I'll add this to the chat as well. Right. So everyone has always access to all of this. Yeah.
Okay, great. Thank you.
Yeah. So Bapi, I think you heard what I just said. We do need to tell the foundation that they are missing a track for ODSA under the general topic or chiplets. Actually, we can create a track, general topic called chiplets, and then go from there. So with that, if there are no other questions, we should start, seeing if Ravi is on call. And the next agenda for today was for Ravi Mahajan to review the taxonomy or lexicon which is used by HIR.
Yeah, unfortunately, it looks like we've had a wait. No, that's Reza. Reza Mogimi has the same initials as Ravi Mahajan. That was misleading.
Yeah, actually, I also looked at RM and I thought, oh, is he online? So did Ravi not know about the call today, or what was the
No,
mix?
we agreed on a date, but I think in hindsight, looking back to my email exchanges, it looks like we never actually closed the loop. Is where I'm at right now. I can swear on we closed on a date with him, specific date. But I think it was a three-way close rather than a.
Yeah, we settled on a date, so I sort of assumed we were all good. But I did not realize he didn't have the link.
No, I know it wasn't just the link. I don't think we ever actually closed on. We never closed a loop with him. I never heard back from him. All right. Hey, anyway, outside of that, I've got some fantastic, awesome, super good news. Our POC is working. I keep forgetting. There's like the bits are wiggling. I wish JP were here online. Young and Ravi are here. Let me see if JP or Vijay, anybody from the hardware team. But the fantastic news is we've got the Broadcom. For those who don't remember our POC, let me see if I can pull up a board description of our POC.
So Bapi, can we include in a coming agenda either on 25th or whenever for POC team to give a quick formal update to the group here?
Yeah, I that's a great idea.
So what day would you recommend?
Not the 25th. Yeah, maybe next week. Next week is that's a good idea. I think to next week, but it is we've got the. It was a huge amount of work because we ran into a couple of glitches. We had to push back the workshop, but right now we can ping. We have a. If I DJ, may I share my screen for 1 second?
Yes, you can.
Just to sort of. This is our POC, and we don't have the lattice card yet, but right now we've got the NXP we've got the Broadcom NIC talking to the x86 host and the NXP simultaneously, and the NXP talking to the x86 host. So this is this finally, it's a result of a fairly decent amount of hard work by Vijay and the Bring Up team, JP and co, and everybody involved. So hopefully next week we can do an actual demo of wiggling bits and pinging each other, etc. But it's incredibly exciting news. It's been a long slog for all of us, and so we're really excited by this. All right. So DJ, I think we need to give it 5 minutes of airtime. Unfortunately, I'm going to give it 5 more minutes. Otherwise, we'll have to, unless somebody wants to. has a panel topic, etc., they want to discuss, I think we may have to call it quits early.
Bapi, I have a quick question. The slide that you just showed, is it available for everybody right now, or we have to wait till next week?
No. So virtually all of this material is available on the wiki. I've just been stealing it from an old deck. You should be able to, if you go to the wiki, this slide is available in various forms, and the information of the POC is available in various forms.
Yeah, I'm just newcomer for this. The
Absolutely.
Yeah,
There is
okay.
the intent is that basically
If you can cut and paste the link for that will be great.
Yeah, so these cards, our intent is to have a live family of daughter cards. So you can put, if somebody comes along and says, hey, I've got an accelerator, we can put it in one of these slots. I've got an FPGA based accelerator, I've got a custom accelerator. The idea is to put in one of these slots and do software development on the POC.
Okay.
Hey, Bapi, if you want, I was just going to do a rerun of the presentation I gave from mine on the 16th of July. I can just do that now, if you wanted to do that, or we can still wait till the 16th, whatever you prefer, on the memory.
DJ's call.
I think we should, Alan, why don't you go ahead, because that will open up the 16th July slot, and maybe we can swap Ravi Mahajan's meeting presentation at that point. So that's a great idea, and that would be a good use of everybody showing up and allocating time. So if you have the presentation available, please go ahead.
Okay, let me.
Awesome, Alan. Thank you.
All right. So just hold on tight there a minute. We just need.
It's amazing that you were that well prepared, man. Thank you.
Well, so it is a recording, but it's very applicable. It's exactly. I'm talking about chiplets in there and into, from a system perspective and the memories perspective. So it's okay. So I'll just play this, and if you've got any questions, if you just type it in the chat, because I'm not actually presenting it, it's a recording. I'll try and answer the questions in the chat in parallel. So let me make this full screen here. Okay, and now I'm hoping you'll be able to both see it and hear it. Let me share my screen. Can you see that?
Yes, we can see it.
Are you recording this one as well, or not, Bapi?
Yeah, we are recording it.
It doesn't. Oh, is it? I don't have a. We don't have a red button. You have pressed record. Okay. It's not saying record here. Okay. Maybe I'm misreading it. So can you shout if you can't hear this as well? I'm just going to press play. My name's Alan Cantle, and I'm going to talk about. Can you hear that? Compute from memory storage in I/O.
Yes, we can hear it, Alan.
Oh, okay, good. And this is an open source hardware initiative. For clarity, when you hear me use the word processor, please take it as meaning CPU and/or accelerator. So as an overview, firstly, I'm going to talk about why decouple compute from memory storage and I/O. And then I'm going to take a look at a bit of a step back at a top-down view of systems perspective, where the industry is trending, and also introduce you to some OCP, the Open Compute Project HPC concepts. I actually lead the actual sub-project in high-performance computing. Then I'll give you a basic overview of the open memory interface, and finally I'll bring it all together, seeing how we can decouple compute using the OCP OEM HPC module with OMI. So, without further ado, first section, why decouple compute from memory, storage, and I/O? Really, we need to start rethinking computing architecture, because the data is at the heart of computing architecture today. Compute is rapidly becoming a commodity. For example, the i386 would retail today with its number of transistors at around 1 cent. Power efficiency and cost are really today's primary drivers, and that's what we need to focus on. And we need to be able to distribute the compute efficiently. It's not the center of attention anymore. So compute therefore needs one simple interface for easy reuse everywhere. So let's redefine computing architecture. Let's take it back to first principles, and let's with a primary focus on power and latency. So in computing, latency is the time taken to move data. More clock cycles equals more latency equals more power. More distance equals more latency equals more power. Hence, power can be seen as a proxy for latency and vice versa. And a focus on power and latency will beget performance, for sure. And we're already seeing this in the heterogeneous processors that have been coming to market for several years now, where they effectively optimize these for specific algorithm types on silicon. But we really need to do this for HPC now, so we need to focus our energy more at the system architecture level. And the silicon level is really taking care of itself to a certain extent. Touching on cache memory, so cache memory is bipolar, it has a bipolar relationship with power, which is our focus now, right? So its implementation really needs rethinking. Cache is very good for power efficiency. It minimizes data movement on repetitively used data. Cache is very bad for power efficiency. Unnecessary cache thrashing for data that's touched once or not at all. Many cache layers of cache equals multiple copies burning more power. Conclusion, hardware caching must be efficiently managed at the application level. Now, I'm not going to talk any more about cache, but I would like to ask for you to park your cache religion chip in your brain to one side when thinking about the rest of this presentation. It's an important topic, and we know it can be managed, but it needs to be thought about separately. But I won't go any deeper because I don't have the time. So today, if you're designing a processor, you've got many interface choices from a latency and a power perspective. You know, from memory all the way up to your distant networks, so Ethernet, and longer latencies and you're burning more power. So your processor designers, they have to decide and allocate beachfront of their processor to each of these interfaces. And the choices are increasing at the moment, making it even tougher decision. And you can live and die by your choices. You may have the best processor architecture in the world, but if you don't choose the right interfaces for a particular application, you find your processor is useless. So this is the way of the world today. So could we simplify this to a shared memory interface? Shared memory has been extremely popular in HPC and the very old days of parallel computing. So could we successfully decouple the processors from the memory and storage and I/O with a shared memory approach? So this is showing you an abstract view of that. We've got our processor and it's nothing but memory directly with the lowest of latency and the lowest of power. So there's an instant benefit there. And as we reach out to the devices that are further away, we gracefully increase the latency and power and through the shared memory infrastructure. So that would allow processor companies to really focus on their core expertise, and they'll be able to support all domain-specific use cases because they just see everything as one memory interface. And so and as systems designers, we'll be able to actually use these devices for each of our applications effectively. So hopefully that answers the why. So let's take a step back and look at top-down systems perspective, and I want to introduce you to the OCP HPC concepts as well. So today we're seeing disaggregated racks to hyperconverged chiplets. So your classic server is really being pulled in a couple of different directions. And why? Well, if we look at the baseline is our classic server, we have physical composability. You can rearrange the devices, remove or add more memory and storage, etc. But in a disaggregated world, it's fully software composable. So none of your resources get stranded as you run different applications. But when you go to the chiplet world, the chiplet world, we really have very expensive physical composability. And I would even argue it's ill-conceived at the moment in the directions I'm seeing the chiplet world go from a composability perspective. From a power baseline, we see that node interconnect is in the 5 to 10 picojoule per bit inside the server. At the rack level, everything's further apart, so we're north of 20 picojoules per bit. And obviously, the wonder of the chiplet approach is we're less than a picojoule per bit, which is the attractiveness of the chip. From a latency perspective, again, you're adding more latency going up and down the rack, and you've got optimal latency in the chiplet. And then from a volume perspective, we've got the volume of the server. You get much bigger volume in your rack scale, and we're sub-cubic inch. So you can see, it wouldn't be remiss in thinking that the hardware people focusing on chiplets don't talk to the software people focused on composability. And I think you'd be absolutely right. And so can we really bring these two together? Is that possible? So it's really being torn apart, as I said. So can we bring them together? So in the Open Compute project, they have open OCP accelerator modules, and they use EDSFF interconnect for a new modular approach to attaching memory storage and networking. So I'm going to show you a module here that's been inspired by these standards. And hopefully I'll show you that this can bring the benefits of disaggregation and chiplets together under one modular standard. And you can see here we've got it would be both software and physically composable. It would be power optimized, so around 1 to 2 picojoules per bit, so not too far away from the chiplet world, and much better than the servers. We would still have a good optimal latency, and the module size is considerably less than the server. So I'll expand a little bit more on that. So fully composable compute module. Again, leveraging the OCP's OAM module, and it's nicknamed OAM HPC. On the left, you can see you still have your big powerful processor on top of this module, and it could even be made up of multiple chiplets as well. So we're not throwing chiplet approaches away. And it has a multitude of interconnect on the bottom for connecting lots of different devices. Taking a closer look at interconnect, fundamentally, we're proposing two different standards at the moment. One, we have 16 of the EDSFF 4C and 4C plus connectors, and we'll have 8 of the near stack connectors. That would give us a total of 320 transceivers for interconnecting from these processors to other devices. And that looks like this module. This one is just an example population. You can mix and match the population. That is the beauty of this approach. But this one's showing 8 E3.S modules, which can be EDL or memory, and 2 OCP NIC-free network modules, 4 4C cables for cabling to other devices, and 8 near stack cables in this little picture. So really, we have a modular, flexible, and composable module, and it's protocol agnostic. The hardware, the electrical signals are all fixed, but the protocol is dictated by the processor that gets populated on the module. And obviously, some processors talk the same language, some don't. So, but that's important. This is protocol agnostic. The memory and storage in the I/O is interchangeable, depending on the application need. And really, a processor must use HBM or have serial attached memory. This does not support parallel DDR memory. But even so, today, this module format could support NVIDIA Ampere, Google TPU, IBM Power 10, Xilinx FPGAs, Intel FPGAs, and Graph Core IPU, as to name a few. So this is a proposed approach in the OCP HPC work group. Now, on the memory side, actually, memory I/O is finally going serial. There have been many failed attempts over the years, but I think we can say it's moving in that direction now. You can see the OMI DDIMM, Open Memory Interface DDIMM, was introduced in 2019, and an E3 format with 2 OMI channels was proposed in 2020. Smart Modular introduced a Gen Z memory module in 2020, and Samsung just recently announced a CXL.mem memory module in E3 format this year. So I think we can finally say that memory is going serial, so our modular approach will clearly be supported by these. Now, just going a bit more specific, let's just pick one of the processors, the IBM Power 10 OCP HPC module as an example. You can see all the connectors I just showed you on the module surrounding the Power 10. The Power 10 has transceiver attached to everything. So here we can see we're supporting 16 OMI channels with E3.S modules with dual OMI on them. We've got a couple of NVMe SSDs plugged into the other ones in the E3 format. We have a NIC 3.0 OCP network card plugged into one of the other modules. And we have a cabled I/O giving you cabling off to some PCI attached device elsewhere. And then we have all the additional cables carrying the SMP and OpenCAPI buses. So this would be the protocol specifics of a Power 10 module that you could then use in this module format. But with this modular approach, so this is that module can be used today with any processor and any protocols and anything, you know, the classic way. But this dense modularity really does bring us a power saving opportunity by leveraging a potentially flexible chiplet level interconnect. So here I'm showing you an X-ray view of the module with the Power 10 on it and the interconnect underneath. And we can measure the Manhattan worst case distances between the die and the chip and the die, the ASIC die on the modules. And we're less than 5 inches worst case. So that really gives us an opportunity to reduce the PHY power to 5 to 10 dB budget, and 1 to 2 picojoules per bit. So it's very similar to the extremely short reach standard XSR of the OIF standards. Also, we also have an opportunity to actually get rid of the packaging on these devices and actually use the substrate, use the module substrates as a package, so we get rid of the middleman, so to speak. And that would again increase power integrity and signal integrity further. And this is this approach with is challenging because they're big substrates, but it's not beyond possibility. So we have an opportunity to greatly reduce the power consumption here. Let's take a look at OMI. So the open memory interface, the graph on the right is a log scale graph, and in short, it shows you that OMI has the bandwidth of HBM at DDR latency, capacity, and cost. So a little bit of a closer, it was introduced in production in 2019. This is not a pipe dream, this is available today and it is very robust. But DDR4 and 5 has much lower bandwidth per die area beachfront, not physically composable. HBM is inflexible and expensive and is capacity limited. CXL.mem, OpenCAPI.mem, CSIC, they all have higher latency and they're termed really far memory, not near memory. And similarly, Gen Z is data center level far memory. So OMI is definitely the best serial attached memory approach to take. This is a bit of an eye chart, but I just want to highlight in yellow the memory interface comparisons. It's the ideal processor shared memory interface. The latency is very much on par with DDR, and the bandwidth is almost 10x per area of that of DDR. And well, more importantly, is very similar to HBM. So because it's similar to HBM, that gives us an opportunity for HBM memory with an OMI-enabled logic layer interface. And that would make HBM much more flexible and have capacity options which aren't there today. So OMI should be considered as a logic layer of HBM going forward.
Sorry, one question. What is the OMI lane speed?
On the Power 10, but I want to highlight. Sorry, sorry.
What is the OMI lane speed?
Lane speed today it's at 32 gigabits per second.
It is NRZ?
NRZ, yeah.
Okay.
3 things here. The OMI PHY, you can see it there on the actual Power 10 die. This is auto scale. The latency adder of the PHY channel is actually 2 nanoseconds in each direction. And you can see that it will drive today a 30 dB channel, so it takes 5 picojoules per bit, but there's an opportunity to drop that with the extremely short reach approach. So that's what I wanted to show you there. But here I also want to summarize this and say, let's look at OMI bandwidth versus our single precision flops, because really OMI is helping to address memory band applications. They have been ignored forever. And so here, if we had a maximum reticule size die, we could fit up to theoretically 80 OMI channels on. That would be 5.1 terabytes per second. We know that NVIDIA Ampere's maximum reticule size gives you a 30 single precision teraflop. So you know, you've got a 6-to-1 there of flop to bandwidth. But as die size shrinks, let's say we shrink it by 7 times the die, the OMI bandwidth reduction is only 2.8, but the flops reduction is 15. So we actually end up with a perfectly balanced 2 teraflops with 2 terabytes per second. So I don't think I've seen anything at decent performance, at least since the 60s or 70s to that level. So this is really quite interesting that we really are putting more attention to it. And we have plenty of capacity behind LMI that you don't have on HBM. So pulling all this together, let's see if we can build a decoupling the compute really truly with the OM HPC and OMI. So here I'm going to look at 1, 2, and 3 port shared memory buffer chiplets that we could create. And I'm going to show it in this module format. So the green box represents the OEM HPC module, and we've populated a maximum reticle size processor with its 80x OMI XXR channels. Let's firstly add an OCP NIC 3.0 card with an OMI 3-port buffer chiplet on board. So we've got one port going to the main big processor. We've got another port which may interface to maybe a little acceleration processor chiplet. So you've got a second port into that memory, and then we've got the third port that would give us our fabric expansion to OpenCAPI, CXL, Gen Z, Ethernet, InfiniBand, etc. So that could be implemented in NIC 3.0. In an E3.S module, we can have a 1 or a 2-port buffer doing something similar, the same. You know, you've got the main port to the processor. The second port could be to an accelerator. Actually this time buried in the buffer if that made sense to do so, and a little tiny accelerator. So that's another approach. As I mentioned, the HBM, we can have a couple of HBMs attached using 8 of the OMI channels to give the same performance as HBM today. From an interconnect perspective, we can the 2-port OMI buffer chiplet on there to convert to the fabric standard of choice. And here you would have the shared memory, a small amount of shared inside the buffer if you don't need the external memory for this. Or we could take the EDSF cabled connector, and actually with those we can actually populate that inside the connector itself. So we actually have a protocol-specific active fabric cable. So imagine that you could plug a CXL cable in to plug to a CXL device, or an OpenCAPI cable in to plug to an OpenCAPI device, etc. This would be truly flexible with this approach. And finally, you could also, if you needed an OMI attached memory, but it wasn't directly local to this module, you could go for a medium reach extender buffer with less than 500 picoseconds of round trip delay adder to actually reach further away OMI memory. So hopefully this gives you an understanding of one memory interface where we truly have decoupled the compute from memory storage and I/O. So once we have this module, though, how do we use it? So the OEM modules actually plug into the OCP accelerator infrastructure. So you can see 3 chassis from Inspur, Hive, and ZT systems. These are real, and they're being upgraded today to OEM version 2. They support 8 modules. So we can similarly support 8 of the modules I just shown you in that same 3U chassis and plug into the OCP ecosystem. The only difference is there is no motherboard. These would just mate to a water-cooled cold plate and also bring the power in through that cold plate. So and this would then plug into that OAI chassis. So in summary, we want to redefine computing architecture with a focus on power and latency. And we want that to be a shared memory-centric architecture. We can leverage the open memory interface for this, and we can use this dense OCP modular platform approach to actually turn it into a practical reality. So are you interested? If so, how to get involved? From silicon startups to open hardware enthusiasts alike, I would encourage you to look at these steps we're taking. Firstly, join the OpenCAPI consortium or the OCP HPC subproject. Replace your DDR memory with standard OMI memory interfaces on your next processor design if you're designing your own processor. Add a couple of low power OMI PHYs with this new XSR interface on any spare beachfront you may have on your processors, so we can start to enable this transition to a completely decoupled compute from memory storage and I/O. Build OEM HPC modules around your large processor devices. Help the community build specific 2 and 3 port OMI chiplet buffers to go out to different fabrics like CXL or OpenCAPI, etc. And help the community to build OMI buffer enabled E3.S and NIC 3.0 modules as well. So I think we're already well underway with a lot of the efforts here, and bringing a wider community together would be great. So thank you very much. Any questions? There's some links to those.
Hi, Alan. This is Shahab. I have one question. How much is the power density picojoule per bit?
So how much is the power density? Well,
Yeah, because you said you're going to be on the 32 gigabit per second and 30 dB loss channel.
Yeah, hang on a minute. So this slide here, is that what you're referring to?
No, the other one, maybe the next one.
So what's the question?
The question is in terms of the power, because you are talking about the 30 dB loss at 32 gigabit per second. I assume that the...
Yeah, so this is...
Halil, I think your microphone is off.
Where's the slide? I need to bring the slides up. I can't see it. It's the IBM Power 10.
Yeah, right.
Yeah, so this is the current OMI channel. So this drives a 30 dB channel. So the proposal is we introduce an extremely short reach one to bring it down to 1 to 2 picojoules per bit.
Okay.
Does that answer your question?
Yes, but do you have any power requirement or power report for existing one for the 32 bit?
Yeah, here it is. This is it. So it's 30 dB, less than 5 picojoules per bit. This is the IBM one, and it's 2.5 watts that adds up to for a 32 gigabit 8-lane channel.
I got it. Thank you.
Isn't this PCIe Gen 5? That 32 gig, or it's some different?
No, it's not it's similar to the PCIe 5, but it's not the same as a PCIe 5. PCI is about 5 to 10 picojoules per bit, so it's less than. I think you're closer to the 10.
My question is similar. If we are going serial, why can't we start with 100 gig? Why do we need to stay with 32?
Why can't we go with
100 gig PAM4? Like, is there anything stopping us to go faster?
Because latency is this is all about latency and power. And PAM4 gives you far too much latency. Look, the critical thing here is this is 2 nanoseconds, this phi. But this is when so back several months ago, 6 months ago, when I analyzed all the different chiplet interfaces, I did my own scoring system, which, you know, it was my scoring system, so I'm not saying it's right. But I picked the Analog X ultra short reach is, I think, what was my winner there. But obviously ultra short reach is a little bit shorter again, and it's single-ended. So you know, after doing further analysis, extremely short reach or similar, and we don't need to obey extremely short reach, we can invent our own. I was talking to somebody yesterday that they think that we can get below a picojoule per bit with an XSR channel. This is not PAM4.
The reason I am saying that, if we are talking to another rack, we need the high speed to lower the cables or the optics if we go, right? Anything stopping us to go to higher speed if we can solve the power problem somehow?
Yeah, this is not, so this is our problem, you see, is this community here in the chiplet world, you're going sub picojoule per bit to get your powers down, but you've got no flexibility. So this is the chart that I had back here. Yeah, this chart. Actually, let me just bring that one. So on this chart, The thing is, your entire focus is, or this work group's focus is all about getting down to less than a picojoule per bit. And let's have a multitude of interfaces. And as a systems engineer trying to put these together, I mean, a processor company, we want to decouple the compute. You can have a compute core that is fantastic, but you've got to be able to put it anywhere. And as soon as the compute people have to say, I need a couple of CXL ports, I need a couple of HBM ports, I need a couple of PCI Ethernet ports, suddenly they're making decisions that really the domain-specific systems engineer needs to be making those choices. And but yes, you've got so you have very, very expensive composability. Whereas the software world is saying we need it all completely software composable, and they don't have a clue about power. Stick it in a rack, make it fully. There's no stranded resource, but they don't mind burning megawatts, terawatts of power, because the software guys don't talk to you guys, and you guys don't talk to them. So I'm saying this dense modular approach is I'm trying to bring the two of you together. I'm trying to give the software guys what they want, and I'm trying to give you guys what they want. But there's got to be compromise. So this 1 to 2 picojoules per bit, and I've been told again, we can get down to 1 picojoule per bit or less with an XSR. If that's true, then that's a pretty damn good choice with all of the flexibility compared to all of these super optimized 0.5 picojoule per bit, or we're just, it's a term in the Britain, gilding the lily. We're overdoing it. We need to have a balance here and just get to one interface. If we're going to make a standard of chiplets, we've got to start somewhere. And I mean a standard that everybody can use. Obviously, the 3D stuff and all of the really heavily integrated chiplet that the big guys are going to do anyway, they're going to do it their way. We don't need standards for that. But if we want to get to, like the server was, a true industry standard that everybody can work to, we've got to get to one chiplet interface that is pluggable in a pluggable form, not just you've got to pay a big packaging company millions and millions of dollars to get your particular domain-specific configuration. Does that make sense?
Yes. But the reason I was saying that for the on-die SRAM, the best solution looks like a 3D integration, because you can pay a very low penalty for interconnect. But if you are going to do a coherent memory to get out of the chip, I will not have that much bit front. That's why the high-speed interfaces, I thought, must make more sense. That's why I asked this question.
Yes. There's a high speed. Yeah, I think the high speed make much more efficient use of beachfront.
Exactly. But that section, I was thinking that maybe if I want to go far away from the rack to talk to another rack or something, maybe I might use optical. If I go that high speeds, it looks like the highest speed possible is going to help me there.
Yeah. So by the way, there's nothing stopping us, and I haven't shown it here because you can only say so much, but it's in my plans. I'm already talking to optical people about this. If we go back to this interface here, right? So this one, you can see we've got the electrical 2-port chiplet buffer in the EDSFF cable connector. And therefore you just buy, you suddenly say, oh, I'm an ASIC startup. I'm a processor startup. I've got my processor and it's all OMI enabled. Oh, I want to talk to an Intel CXL processor, and I want to talk to an IBM OpenCAPI, and I want to talk to an NVIDIA NVLink, and I want to talk to AMD over Infinity Fabric. I just buy 4 different cables, and I can talk to all of them with my own startup processor. If you're a startup, that makes a hell of a lot of sense. And so you put the chiplet in there. Now, if we go that way, if silicon photonics is really going to take power of optics down from your big QDD modules, your QSFP modules that are huge and power hungry, down to sub half a watt, then we can actually replace that with an optical buffer and have an optical cable coming out of that connector. So suddenly I'm a systems engineer. I want to buy a 1 meter cable or a 1 kilometer cable. I just buy the cable with the optical or the electrical buffer in it, and I don't care. I'm a systems engineer. I don't care whether it's optical or electrical. I care about price and distance. And so suddenly I've properly decoupled that. Now, If you say, well, actually, what about co-packaged optics, where I can get 64 lanes and the interconnect will never do that electrically? Well, I put my buffer, my optical buffer on the module and bring all 64 lanes into that, and then have one fiber coming out or whatever, and then I just do a version of the connector which includes an optical coupler in there, and then I can just plug optics straight into the back. And so that's my proposal. So you don't have these horrible co-packaged optics coming into the top of the module. They're coming into the bottom just like everything else. So this works for co-packaged optics, and it works for cabled optics like QDDs.
Awesome. Thank you very much.
But good questions, very good questions. And I'm not saying I've solved every problem. This has challenges from every single direction, and this is what I'm trying to do. I'm actually bashing down lots of verticals. I'm working across boundaries. You guys are specialists in chiplets. You know, the software engineers or the signal integrity people will be concerned. People that make these substrates will say, can you really build a substrate that big? There's a ton of engineering problems that we need to overcome, and that's what we're trying to do in the OCP HPC work group. But what I'm trying to do here is get people to see the vision of the beauty of one chiplet interface. This is a TTL of 2020s, because the TTL worked really well in the 80s. There are lots of silicon companies that made lots of money out of selling small TTL chips. I think suddenly the microchips, the RAM buses, anybody that actually makes, any of you chiplet specialists can make these buffers and sell millions and millions of them without a problem. But at the moment we're all waiting for the big incumbents to tell us what to do. But this is obvious that this is the best way forward, and it decouples compute. Now the trouble is, if you think about it, the big incumbents, what are they? They are compute companies. This is the last thing the big incumbents want you to do, because it suddenly takes the center of attention away from them. We're not CPU centric anymore. We're now data centric, and suddenly they lose it. And we have a Tesla event going on, maybe, if there's a good startup there, or at least we have a democratization of our industry from the incumbents right now. And really, I think to the Facebook people, and the Google people, and the Microsoft people, all the big hyperscalers, this is the way to suddenly democratize the industry and get the competition going again, so you don't have to pay Intel's prices or whatever the problem with the hyperscalers is. So this just makes perfect sense to me, and I'm just desperately trying to get some traction here of the big members to say, let's try and make this happen. Anyway, sorry for the passion. Pappy, back to you.
Thank you, Alan, for sharing this. Do you have access to these slides? I know the call is recorded, but it would be nice if we could post the slides so people can view them whenever they have time.
Yeah, no, I can send a copy to you, DJ and Bappy, and yeah, I've also got well, obviously I've got the recording as well.
Awesome. Yeah, we'll post it on the ODSA website so that everyone, along with the call details, so that people can access the presentation.
Okay, I'll send it. I'll send it to you and Bappy then, and you'll post it, or do you want me to?
No, just send it to us and we'll post it on the OCP website.
Okay, perfect.
Both of them, right? The presentation data and the recording, right?
Yes, everything will be on the OCP website. That's always the case, Michael. So we do this for all the past recordings. They are all available for public viewing on the OCP website. Yeah, and then we attach presentations as they become available, so that recording is available, but sometimes you just want to look at the presentation, not listen to the recording. You can do that as well.
Okay, thank you.
So I think we are 7 minutes to starting the next call, which is the business work stream call. So any quick comments, thoughts, and then we'll do a roundtable to cover any opens, and then we'll close the call. So any thoughts, comments? So let me just go through Bapi, Alan, any opens?
I'm good, thanks.
Nothing,
Michael?
DJ. Well, I do have one.
Okay.
I think this guest hosting idea has been a spectacular success. So anybody else, if you want to host a weekend call, please ping me.
And I think we can use meeting minutes as well to add to, I think people have access to the document, so you can also add things to the document directly. Michael, Anu, any opens?
No, and sorry, Bapi, that I didn't complete that circle with Ravi. I
No
sort of
worries.
assumed it was he would know for some unknown reason. So.
It happens. Don't worry about it. We'll get
I
him
think
back.
it worked out well, Anu, with
Yeah.
Alan stepping in.
Thanks
So
to Alan. Thank you, Alan.
Yeah. So what we have now, Anu, is we have Ravi Mahajan scheduled for 16th of July. So let's make sure that he knows that date.
Sure.
Perfect. Shahab, Halil, any opens?
No, thank you.
Not on my part, thank you.
David, Giridhar?
Nope, I'm good, thanks.
Young, Mudasir?
Nothing from my side. Thank you.
Suresh, Kevin?
Nothing for me.
Nothing, thanks.
Ravi, Swami, and Carrie?
Not from me.
Nothing. Thank you.
Sorry, I'm good.
I'm good.
Craig, Peter?
No opens.
No, nothing for me.
Quinn, William?
Nope, I'm good.
And Roberto, Swami, and Lee?
This is Roberto. I'm fine, thank you.
Okay, perfect. So before we wrap, Lee, do you have any comments?
I'm fine too, thank you.
Okay, thanks. So before we wrap
No,
up,
I'm fine too. Maybe I.
Yeah, go ahead.
Oh, okay. Yeah. So in general, for Alan, can we use like a bunch of wires for the open memory interface, or it has to be?
Good question. So you're on about the file layer now, right? So technically you can use any. So I'm out of my domain of expertise. I've learned everything from listening to you lot. So the OMI today in the current PHY is it 32 gigs?
Very nice presentation. So I think people are seeking for large module scale kind of packaging, and that will basically combine very well with your what you have presented.
Okay, so yeah, I guess if a bunch of wires could go at 32 or higher, but I guess the challenge I've come across is that you can't get quite the speed. So we need 32 today. We'll quickly progress to 40. I think the Analog X XSR currently runs at 40 from the spreadsheet that was put together on this work group. So and we would like a roadmap to 50 NRZ or more to keep up with the memory.
But there's a problem there, right? Bunch of wires, a parallel interface, a clock forwarding. How are we going to solve that if we do it this way? Can it be useful here?
Yeah, this uses a synchronous clock, so it's actually a full synchronous channel all the way. So I think that means you could use clock forwarding, but it means you've got a synchronous clock all the way through to the memory. That's part of. There's a major latency story in the OMI implementation. So your link layers, your data link and your transaction layers are pretty critical on that implementation to get the latency down. And you need an interface with a very low bit error rate, 10 to the minus 17 or something, because memory channels are not forgiving to errors and retries, whereas fabrics have to deal with errors and retries. So so the file layer could be, as long as it can meet the parameters of routing over 5 inches, then a bunch of wires, the terminated bunch of wires may be the way forward, but I fear that it's too slow. That's why I get faster interface.
But isn't there a need for like arbitration in between? What's inside of SOC versus like compute SOC versus what's been attached there? Because you don't have the priority of which communication is higher or lower.
That's the beauty of shared memory. So if you understand shared memory, what you do is literally everybody can see the memory through the 2 or 3 ports. Well, obviously, if there's only 1 port, it's your memory, but if there's 2 or 3 ports, you have to actively manage. And in high performance computing, shared memory is done by semaphores, doorbells in letter, where you say, I own this memory for the time being. And once you finish with it, you say, now you can have it. So there's no copying of the memory like there is with caching. So therefore, you really truly save power. Now you can add cache inside the memory buffer. And I think that was what Steve was talking about a few weeks ago on this call. And so basically, you put the fabric intelligence into the buffer when you want to.
Hey, Alan, I think we'll have to cut this call short. Sorry about that. We have a ODSA business call starting at 9. So one last comment to everyone, please be ready to discuss your abstract, whatever you submit in the next Friday call. And with that, wish you all a fantastic Friday, and we will be talking to everyone. Ravi Agarwal is leading the ODSA business call, so we are jumping on to that.
So DJ, maybe what we can do is stop the recording on this one so that we can start the separate recording after this.
Perfect. So Bapi, can you do that for us, please? You have the comms for the recording.
Good
This
morning,
conference
everyone.
will now be recorded.
No, we are transitioning into Chiplet Business Work Group call. Maybe we'll give one or 2 minutes so that people can join, and people who were in the previous call, feel free to stay if you want to, or up to you. Rishi, I'm seeing you after a long time.
Ravi, there's always a conflict with this time, and I have a key engineering meeting at the same time.
I see.
Today actually is a cadence holiday. We have off today and on Monday.
Oh,
and
nice.
That's the reason. It's not that I've resigned or something like that from this role, but it's just that the 2 conflicts basically, my priority comes on my current employee role. That's why.
No worries. I was just checking because it's been a while, and I was even thinking to ping you separately.
Yeah. In fact, I've been actively working on this stuff on a lot of fronts, to be honest.
Okay, I think we can start. So today I sent out the agenda, and so agenda for this meeting is being now part of the meeting invite. There is a Google Doc where there is a link in the meeting invite, so everybody will have access to that. And today, so do we have Roberto? Yeah, we have Roberto. So I would like to introduce Roberto Rotlili. He's from Teradyne, and he has agreed that he has agreed to help us in with the known good die and the chiplet security aspect of it. Roberto, I'll let you introduce yourself.
Yes, sorry, I was just trying to try to get some system preferences to get my mic access. Yeah, so I was going to lead the discussion. I think it's the second
Yeah.
item on the agenda around known good die and security, as was mentioned. I work closely with Regan, kind of been with the company for 15 years, started on the engineering side, and then the last couple of years been moving into marketing and kind of running part of the marketing group and the general manager for semiconductor test. So I'm looking forward to having the discussion, kind of getting the feedback, and kind of furthering our view on what known good die is for the chiplet world, and then kind of really starting to scratch the surface on what it means for security, all with, of course, a business focus, right?
Thank you so much, Roberto, for spending your time and agreeing to help with this ODSA initiative. So with that, before I let me share my screen, and okay, let me know if folks can see my screen. Okay, so the agenda for today is we will have cost model discussion, and last time when we met, Mudisar also suggested the economic model of chiplets, and then Anu and Javier were planning to meet with him offline, so we'll have some discussion on that, and then Roberto will lead the known good die and chiplet security discussion, and then I would like to have a last 15-20 minutes to have a discussion. How do we, this blog group will participate in OCP Tech Week. I had some initial thoughts, but I would like to get input from everyone. So that's the agenda. And the next meeting after this, we will have just before the 4th of July weekend. I am thinking that's on 2nd July. I'm thinking of canceling that because a lot of people will be on PTO. Any feedback, input, or you want to keep the meeting, but I will be on PTO, and somebody else can cover me?
No, I think we should just cancel that week's meeting.
Yeah, I'm canceling the main meeting too, Ravi, if that makes
Oh,
a
perfect.
difference.
Yeah, so then I think we should cancel this as well. All right. So then, which means we will be meeting probably after 4 weeks from now. So any suggestion on rolling agenda?
I think one area where we should continue to push for is on the taxonomy and lexicon. I think it would be good if we agree when we will publish the first draft of that, Ravi, and group, and that puts a very clear deadline. Otherwise, it's just difficult to kind of get closure on some of these things.
Thanks, Dharmesh, for the suggestion. Originally, I was thinking to do it today, but I think Ali is on PTO today. So, but definitely that should be for our next meeting agenda.
Well, I think the other thing is the idea was to have Ravi Mahajan present, because I think HIR has a good handle on this, and since that got pushed out to, did you
We
say
close the loop,
mid-July,
Anu, sorry.
Dharmesh?
Anu, sorry, I'm going to interrupt you. Ravi just responded, we're on for 7:16.
Okay, so since that's moved to 7:16, I would suggest we don't try to close this issue before that, right? The idea was to reuse what HIR has and expand on that, and at least have us and the HIR be in congruity with each other.
So Anu, it will work perfectly because this next meeting will be doing on 16th of July for this work group.
Okay.
And I think right after Ravi's talk, probably that could be a good discussion for us to see how we can converge.
Oh, good. See, that's what I did, Bapi. We did this purposely to make sure it all lined up.
The master plan.
It is.
Okay, I think we can discuss more about the future agenda. Any other suggestion? Otherwise, I will move on to today's agenda. Okay, with that, Anu, Mudasar, do you want, and Javier, do you want to start like what you guys have in mind for cost model?
Sure. I guess we can. I can cover it, but Anu or Mudasir, please jump in. The discussion we had was on the variables that are there, and the model that Mudasir has put together is much more comprehensive than the more simplified, simple partition approach. To just that was meant to demonstrate that the partitioning a die, even though it grows, it becomes much more economically viable. As a point, I just wanted to show that. But Mudasir's example is a bit, it has a lot more of the constraints in there. So what we discussed was, how there may be almost too much for easier and general use, but the way this is envisioned to be constructed is that there could be adders or additional modules to consider more things, but it wouldn't be required in doing this analysis. So, Anu or Melissa, please, chime in with any additional detail.
That's right, Javier. Exactly as you said. What we did was the three of us met, and as we all know, the chiplet problem is complex. It has, supply chain implications, material implications, test, known good die implications. So an actual detailed model will be obviously very sophisticated. But as Javi pointed out, we don't want to make it so complex that people don't use it or get turned off entirely. At the same time, we want to make it useful enough that they have some meaningful value out of it. So we're hoping to produce a model that essentially is built in modules, one that would be a basic, simple model, and then add more sophistication to it as people may be more interested or want something more precise. Now, Javi and Anu, I sent you guys a spreadsheet. I don't know if you had the chance to look at it, but the first version is basically a Google spreadsheet that essentially has several of the factors. It doesn't have things like uncertainty and other things, but do you want to comment on that or any thoughts on that?
I actually didn't get a chance to look at it. I sent you a quick email this morning about permission, but
yeah, I gave the
sort of,
permission. Yeah.
Okay, I totally support that, and that was kind of my email to you earlier this week about my first attempt at removing uncertainties. And I, of course, had some questions on some of your entries, which I think that you've elaborated on those. So, so Ravi, this is going to take, a few more iterations. Mudarris's put in a lot of thought and work into it. And it
So
can get
do
to
you
be
want
really
to share
complex.
at least, do you want to share at least how you are thinking? I know it's not done yet, but see if you want to, there are other places where you seek some help from some of the industry partner, Mudassir, or do you want to, how you want to approach it?
Yeah, so what I can do is I'll share with you what I shared with Javi and Anu yesterday, and walk you through it. And yes, at some point, of course, we would like inputs from, I'm pretty sure no one person can build this complex model, without inputs from someone else. So let me share the spreadsheet.
Actually, I was asking, do you want to share now with the broader team and get input, or you would prefer to reiterate between three of you first and then come back?
Yeah, I think that's a choice among the three of us. Anu and Javi, what do you guys think? Do you
Yeah,
want
I
to
think
talk
we
through
should
the factors now, or first we want to go internal?
It's probably best we start internal and then bring it up to the larger audience.
Yeah.
Ravi, I think what we can do is just add them in the rolling agenda. Why don't
Yeah.
you pick a date? Yeah.
Yeah. Okay.
Yeah, because I think people in this team actually could give us really very specific feedback as they come from different, pieces of the flow, like Elko and Swami, and so it might be too messy right now. But
Yeah, and I think adding us as a rolling agenda would be easier because that way, as we keep evolving it, you can get inputs.
Okay. No, fair. So I think we'll plan for the next time, which is on 16th of July. See where you guys are and then what help you need, because I'm pretty sure there will be some component needed from, especially from Elko and Swami from a packaging standpoint, and then Roberto from a test standpoint.
Yeah.
Okay. With that, I think anything else you want to add before we move on to the next agenda?
No.
Okay.
Actually,
I have a quick question. Have you guys thought what support might be needed on the design exchange side, on the data exchange side from CDX?
We at some point, I think we will socialize this with the CDX folks.
Okay.
But I think this is still pretty high level. I don't think we will be to the level where we would need that detail yet. But as we add more modules, we will definitely socialize this with the CDX folks and make sure that we get their inputs as well.
Right. Okay.
Yeah, I think eventually it'll all tie in
would be awesome.
together, but maybe right
Yeah.
now it's a little
Yeah.
preliminary.
Yeah. Okay. Let me know when you're ready. Feel free to come by to the CDX meeting and present, and we can talk about what's needed.
Will do, David.
All right. Awesome. Thank you.
Thanks, Anu, Mudasar, and Javier. So I think the next agenda we would like to move on is known good die and chiplet security. And I think, Roberto, floor is all yours.
Thank you, Ravi. Let me share my screen. You guys see my screen?
Yes.
Slide showing you. I borrowed the Open Compute project template. So let's see. You know, I already did an introduction. I really want to have a discussion around and get a lot of feedback from the people on the call around known good die. You know, obviously we put a business spin to it and chiplet security. And so I've got about 3 slides. 2 slides will just be focused on known good die. 1 slide, I think, I would imagine most of you or all of you have seen it. I made some tweaks to it. I think it's one of the slides that Regan had presented. And then have a couple of slides that really lead the discussion to see if we're thinking about it a way that makes sense to kind of the community on the call. So, you know, known good die, right? I think the statement we really want to make, and I'll go through the slide, it's really kind of a comparison around when you start looking at, you go from fab to package to shipment to the end customer, just kind of what it looks like today for a monolithic piece of silicon, and then what we think it'll look like for a chiplet-based SIP with a heterogeneous solution, right? So not a vertically integrated Intel putting all their chiplets in a chiplet SIP, but really pulling kind of the intent pulling chiplets from different vendors. And then really some cost factors. Obviously the focus we'll have on the bottom of this slide. But I think the theme, what one would pull away from it is that the value of quality is kind of shifting with chiplets to the left, meaning you're going to want to get a better known good die, and we'll kind of work through the logic and test it with the group here and whether that makes sense. And then of course, you know, we'll get into why we think that is the case. And then I got another slide where we just tee up some questions that I'd really like to kind of put out to the group and see what they're thinking. So on the monolithic silicon, it's, you know, you get a wafer out of fab, you do the wafer test. Very important to catch all of the failures at wafer test, because you know, then you're going to go spend money on packaging. You know, and then of course you're going to spend money on testing after the packaging. But you know, depending on the process node, packaging and the die size, packaging can be incredibly expensive relative to the cost of test here. And so, you know, having good die kind of coming out of the wafer, which some companies buy the wafer and then they go spend the money on the packaging themselves. And so this is how it looks like. You package it, you test it again, and then, you know, we put a system level test block here. I think a lot of you are familiar with system level test, but we do see system level test playing more of a role, especially in the compute space, as the complexity and the transistor count starts doubling every 2 years, and I think it's becoming expensive and difficult to capture all of the failures at the ATE level. So system level test becomes a thing. Now, on the chiplet-based SIP heterogeneous solution, right? You've got a lot of different chiplets coming from fabs. You're going to want to be doing some test here. We'll describe some of the challenges on testing chiplets, especially because chiplets are now having this die-to-die communication. And that die-to-die communication, I think the OCP is driving a couple of standards, is not really designed to be driven off chip. So ATE plays lesser of a role, and built-in self-test, I think, plays a bigger role. So you've got your known good die, then you spend some money to assemble it. Then you kind of, you might be doing a smaller chiplet-based SIP. Then you want to be testing that, and then you're kind of eventually aggregating all of your chiplets from different suppliers into the final package, and then you're kind of doing your test. So the bottom of this slide, like I said, I think some of you've seen it if you haven't. It starts, the scrap cost starts getting more and more expensive, right? Throwing away a bad chiplet is expensive, but far less expensive than throwing away 3, 4, 5 bad chiplets that are kind of put on a SIP. And then ultimately, when you're at the end stage here, where you've kind of combined 15, 20 chiplets, and maybe the COGS of the SIP is around $30, depending on the end application, and you catch the failure here, you're kind of throwing away a lot. Now, what would also make known good die really having good quality here really important
guys,
for.
Sorry, could I interrupt? Could everybody please mute? We're getting a lot of feedback from somebody's line.
Hopefully it's not my line.
Thanks. It's better now.
Yeah, I promise I'll talk for 30 more seconds and then pause, because I'm sure people want to chime in here. But I think one of the comments that are in the cost factor is, if you're a vertically integrated chiplet builder, right? And you're combining all your chiplets, and then you catch the failure here, it's very expensive. So, you're throwing it away. But now imagine there's 15, 20 different vendors that are supplying chiplets, and a vendor is supplying maybe a 50-cent chiplet. It could be a simple IP block that they're putting on a piece of silicon, and all of a sudden you're this vendor, and you're now responsible for the failure at the bigger SIP level. And now, you're a 50-cent component, and now your end customer has to throw away a $30 chiplet. And so I think we'll get into a discussion on the next slide. I start teasing it out. I think what you're going to end up seeing is what's going to drive known good die requirements is going to be a factor of what's the scrap cost, and what are the liability contracts that you're going to have with the end vendor. So if you're this 50-cent chiplet supplier, and you've got some quality metric that you've got to meet that's in a contract, and all of a sudden there's a quality excursion and you can't meet it, and now are you going to be viable, which I would imagine, are you going to be liable for the scrap cost? And if the answer is yes, you being this chiplet provider up front are going to want to have a very, very good quality control program around wafer tests before you start spending money on the substrate. So I'm going to pause. I've got another slide where I tease out kind of more ideas, but I want to hear what people have to say.
Hey, Roberto, so this is DJ. I have a question. In fact, this is the crux of the problem, right? The way you laid out in the very first slide. This is excellent. The question I have is, do you have any thoughts on what kind of SLAs could be, put in place for transfer of a known good die from a party A to party B, and then party B to party C, and so on and so forth. Any thoughts? Because that's the point, right? That when I generate a 50-cent chiplet with IP on it and I give it to you, Roberto, for further assembly, when I transfer it to you, we have certain agreements where you look at it, you accept it, and once you accept it, then I would assume that you would take on, going forward, certain responsibilities for handling it and so on and so forth. So maybe there is some standardization of these transactions which are happening. These are all going to be either two-party transactions or multi-party transactions. So do you have any thoughts on any standardization which can be created by this business group, or areas where we can leverage commonality so that same rules and principles can be applied as it goes down that flow chart which you're showing?
Yeah, I took a note because I think that's going to be. I have not well thought out ideas, and I absolutely agree that is an output of kind of the known good die problem statement, which we kind of outlined here. And I'd really like to work with the group and seeing if we can come up with exactly that. And I think it's going to be challenging to have a template or something standard that everyone's going to go agree with. I think there's going to be a lot of different power in the supply chain, and depending on how much, how value it's going to be a lot of contracts, and it depends on how valued you are as the chiplet provider and how much leverage you're going to have, where you're not going to be full on responsible for the scrap costs at the very end.
Right. Fair enough. And in fact, we are all trying to solve that problem collectively, right? So identifying right problem is as important as actually rushing to come up with some answer, right? So identifying right questions and right problem can also contribute to the general community movement. So we can keep working on it. So the follow-up question I have, Roberto, is obviously that flowchart today exists in proprietary systems. For instance, AMD must have a flowchart like that, and NVIDIA and Intel and so on and so forth. Do we know, or do we have insights into what kind of transactions companies like AMD undertake, or typical in the industry in terms of when a big player is putting all various chiplets into their system and package, what kind of things transact across them and the chiplet provider? Anybody has insight into that? And we can use that as a way to bring some ideas into the same problem statement for the open ecosystem.
I think so. I would like to emphasize what Dharmesh basically mentioned, the second phrase, right? The ecosystem, because normally this whole food chain is governed by one entity or one organization. So it's a closed door environment. Like if you take an example of AMD or NVIDIA or even Intel or any organization, both the parent die and the chiplet die is kind of governed by one entity. So there is more control environment. The challenges happen when it goes into the ecosystem and cross-pollination happens.
Right. But Ravi, even, Rishi, even in the control environment, do we know, for example, what are the criteria AMD uses as a checklist to kind of transact with the chiplet vendors? I'm sure a lot of this information may not be publicly available, but the thrust of this question is what exists today in the monolithic, like a single company environment, chiplet environment, which we can leverage for the open, equal and open system environment.
So
yeah, good. My only one statement is I'm sure the parent company knows about this. I don't know whether we have the rights and the authority to disclose it. I let the experts on the fab side talk about it much more, but it would be prudent if somebody from a company which has chiplet-based product could share that insight. I'm dead sure they have it.
Right. Yeah. Makes sense.
If I could add a comment, I think, this issue here that's being highlighted is exactly the reason why chiplets are really limited to vertically integrated companies today. So with the exception of maybe HBM, the chiplets that AMD or Xilinx or whoever are using are all done by themselves. So there is not a third-party chiplet ecosystem yet. So yes, there's some learning to be done, but these companies are basically, if you think about it, they're following their same design process as a monolithic die. And they're just looking at the cost trade-offs of chiplet versus monolithic, but everything is under their control.
Yes, I second what Elko just mentioned. The industry has system and package today, SIP, and a company can have silicon coming, say, from Broadcom or anybody. Since Baptisia, I'm just using Broadcom as an example. So yeah, but the design is controlled by them, by the parent, as Rishi also just mentioned. And that's why they're able to design it and then procure it and then do their testing. And as Roberto just mentioned, you do system level test and they're able to test it out. But, the very first meeting here we had, there's a question we had all asked, who's going to own this? There has to be one identified owner who's going to own this design. And even when, the final chiplet has to be owned by somebody. It cannot be just open there, right? Somebody's got to sell this product and they've got to take the ownership.
So Swami, I'm going to jump in. Actually, what I intended was a little different than the SIP story. So in SIPs, what you're integrating is basically finished ICs. So these are dies that function completely independently. They are a little different from chiplets in that chiplets, as I think Javi once described it best, are, they don't have all the traditional IO buffers and all the other things. They're not really dies that are meant to function on their own in a discrete package environment. So when you're talking about SIP, you're generally using dies that are discrete dies. And that's where, certainly KGD comes in there if you're not using things like wafer level CSPs, et cetera. But quite often, you're using wafer level packages and other types of approaches. But when we're talking about die partitioning, heterogeneous integration, having, PHY die that are chiplets and things like that, the only people who are using it today are the Intels, the AMDs, the Xilinxes, who completely vertically integrate everything. So those chips are all co-designed by that supplier. And as you've said, I'm sure they have methods for looking at, what the yield implications are and what the right level of known good die are. But that's still different than talking about a third-party ecosystem for those types of chiplets and what kind of warranty and yield information has to come with those dies. So that model just doesn't really exist yet, with maybe a few exceptions.
Yes, Elko, I do agree when it comes to the design aspect, how you're going to, assemble it all together or put together, that it doesn't exist. But I guess the business model has to go and make this happen, with one company dealing with multiple other entities to enable their final, SIP. It does exist today. Is the point I'm trying to amplify. So the question again comes down to who's going to be responsible for this design. There has to be that single parent owner who's going to enable that, right, for this business model to succeed.
So Swami, how about, I've been thinking about this, and maybe it's Swami into the group, right? Like, what's a good comparable? And I think my reaction is a vertically integrated chiplet-based SIP today is not a good comparable. But what about if you take a phone and you explode it, like the PCB of a phone? It's the closest thing we have to a comparable, and I think we all agree there's some significant differences between a chiplet-based SIP and a phone. But it's kind of, you have someone who's ultimately responsible, right? So the phone manufacturer, they're aggregating chips, and by the way, and it's not lost on me that it's easier to replace a defective chip in a phone than it is to replace a defective chiplet in a SIP, right? That's, in fact, it's probably not replaceable or repairable in the traditional way we think about it. My next slide, I kind of open up some ideas, and I really wanted to introduce some ideas to the team to see what you guys were thinking about. But I don't know, what do you think about using that as an example? Like, for, everyone's got a contract on quality, right? If you're putting everything in a Samsung, I'll use Samsung just as an example. I don't have a Samsung phone, but if you're supplying the application processor, say you're Qualcomm, and you and you don't meet your quality excursions, and a lot of these phones are kind of coming back, those contracts in a lot of cases look like you're responsible for the scrap of the whole phone. If you can't meet your quality goals, you're responsible for paying for the phone if you're below this threshold. And I haven't studied all of the contracts, but I'm wondering, without getting into too much details, do we think that's a good place to start studying and seeing if that model is even applicable to something like this?
I think at this time, this is the only model. There need to be an integrator, and that integrator bears the responsibility. And how does he have a contract with the individual suppliers? But in the very end, there is one person or one company, one organization that is an integrator for the chiplets.
I think it also matters on what kind of chiplet you're buying for this KGD concept, right? Because Microchip does buy third-party chiplets for some of our chips for integration, but a lot of it is just memory, flash type stuff. And with that, I think the known good die process is a lot easier because it's memory and it's repairable. So worst case, you can go fix the damn thing. But if you're doing something other than that, then it becomes an issue, right? I mean, then it becomes more complex, and I don't know what the rules at that point are. So just my 2 cents worth here.
Yeah, that, by the way, that I'm tempted to go to the next slide just because your last comment on memory is repairable. There might be, this is a busy slide with a lot of words, but just to, maybe if you're a chiplet provider and you have this contract on quality as a hedge to insurance, maybe you make your design more repairable. And so I think we all know how to repair memory, right? If you have more memory banks than you really want. If the memory banks fail, you kind of disable them. Maybe you start thinking about that if you're providing DSP cores. You provide a couple of, in your design, you have a couple of extra cores, then you're really promoting and selling. And if some cores are failing because of the manufacturing process, you could enable the other cores. Or you maybe if you jump back and you have more redundancy in your design, which, by the way, it'll increase cost. And so I'm just going to highlight, I think we talked about a lot of this stuff here, but kind of really maybe you have to make, because we know how the contracts are going to end up, right? If you're a small chiplet provider that's kind of a commodity and you have a quality excursion, the contract's not going to be in your favor. You're going to be responsible for the scrap cost, and that can probably wipe out all your profits depending on how bad it is and what your margins are. So you might want to have a hedge in all of your designs, because the other challenge that I think we all talked about, you can't really test chiplets as thoroughly as you test a monolithic SIP. It's not apparently obvious on how you could do a thorough test coverage to the point where you feel incredibly comfortable shipping it as known good die. So there might be a hedge on, where you have redundancy in your design, where you can make it repairable. And I know we're pressed for time a little bit, so I'm going to make one more comment, and then we can decide whether we want to jump into security, because I'm sure that's another rich conversation. Does good now mean the device I actually bought? So when you think of known good die, I tried to connect the two topics. Maybe I was being too cute, but does the device work, right? Does it meet all of the electrical and mechanical specifications that me, the buyer of the chiplet, meets? And is it the chiplet that I wanted it to be? Meaning it's not a Trojan chiplet, right? Where there's a bad agent in the supply chain and now I'm going to lead into the security, because now when you have chiplets and you're the aggregator, right? You're the builder of the SIP. You're now going to be maybe buying relatively easy to clone IP blocks from a lot of different people, and trying to hijack, trying to have Trojan hardware in a monolithic design is really complicated. You got to steal the production mask. You got to have an inside job. But now all you really need to do is maybe clone easy IP and build, and kind of infiltrate some easy IP chiplet into the overall SIP. So I'm going to hesitate to really jump into security yet, because I wanted to have people think a little bit about having more repairable IP. And is that going to be an extra design cost that you're going to want to have?
So on repairable IP, some architectures will lend themselves well to that, and others will just won't work. Even in memory, you can repair it only if you have a certain number of bits in the array. But if the error is in the controller logic, it's not repairable, right? So even that's got its limitations. So if we take, since you mentioned cores, if you have many small cores, having a bit of overhead isn't that much of a tax, a burden on the chip. But if you have large cores, having a spare is tricky. So then the flip side of that is, rather than have redundancy, have the ability to only leverage, I guess, the equivalent of like a down binned part. The 4 cores didn't work, I can only use 3 and still move along, right?
That's an interesting. I was thinking about that comment but here's the thing, if you're, I'll pick AMD, maybe you're okay down binning because you've got 3 SKUs and you're going to sell it. Maybe you're not as happy, but you're going to sell it anyway. But imagine you're the aggregator and you really want to get the best performance out of it so you can get your best price, and all of a sudden you're down binning because of this quality excursion. Like I don't know, there's just so much there.
I think so there
right?
are 2 issues over here. This is Rishi, I just jumping in. We are
Yeah,
going into one part of it is the functionality in terms of the die yield, and where memory failure and all those things happen. And the other aspect of it is failure during the integration phase, where some lanes are not, when you integrate it and there is a data path lane or the wires between the chiplet and the parent die, they are failing by the nature of integration or some damage being done. So there are two aspects of this kind of analysis. And on the BIS side and the repair side, it's purely a design function, whether the design takes care of it. And similarly, even during the integration, if some lanes are damaged or not integrated properly or have an SI issue where they are not operating at a proper electrical characteristics, that also can be taken care by design by having redundant lanes or lane swapping or those type of functionalities. The second aspect on the security, I would like to highlight that you could mitigate that by something like PUF. You have the PUF installed on your chiplet and the key of it is in the parent die. In that way, the two organizations who are having a handshake between the chiplet and the parent die can have a secure key, lock and key mechanism between the PUF without complicating the aspect of security, where no Trojan or no, I would say, fake IP or IP protection can be taken care, and you will have a proper secure aspect between the chiplet and the parent die through this lock and key mechanism. And I think so many of the organizations today, like Broadcom and few others, have successfully implemented the PUF concept, and it's there even in the FPGA space.
Thank you, Rishi. Yeah,
Yeah.
I agree with the approach on the PUF concept, which is kind of leads me to this. And I know there's other topics we want to hit, so I'm trying to be conscious of time.
Yeah, so Roberto, I think this is a great discussion what we are having today. So security, I think we should probably go dig deeper next time. Because so my question is, before we switch gear, what should be our next step on this topic, known good die? I know we have a lot of good discussion today. Is it something like how you want to approach based on the? I think this is the first time you hear pretty much a broader audience. So how you want to structure it, and how, like any suggestion from you or from anyone?
So I have a suggestion, Ravi. In fact, this line, a dollar chiplet provider on a $30 SIP, kind of triggered some thought processes. Can we, obviously, when people are putting SIP together, there would be a universe of solutions where you have 2 vendor SIP, 3 vendor SIP, 4 vendor SIP, so on and so forth, right? So the point I'm making is, maybe majority of the solutions initially, which are system in package, might be just interaction between two companies, meaning we are not looking at solving a problem of assembling 3 different vendor chiplets together by the 4th vendor or something. So if we simplify solution space and then guide business requirements for those simple solution space, that might be a good way to make problem manageable, instead of trying to solve for all different possibilities where you have n number of chiplet providers and one big SIP. Perhaps we should think of solution set by saying that 60% of solutions are primarily somebody building their own chip with maybe one IP from one vendor, and that can be an open IP, or maybe 60% of the solutions are one big SIP builder with 2 possible IP, something like that, and just make it very simple. And then perhaps that can make the whole problem of moving through the known good die easier to manage. So that's just one thought I have. I don't know if I made myself clear, and if anybody else has any comments to that. And I'm happy to clarify if people couldn't understand what I was saying.
Yeah, I like the idea, right? Instead of solving for the most complex use case, which is a lot of chiplets and a lot of suppliers of chiplets into the SIP, maybe we can start with something that might be more realistic, fewer vendors, maybe one's a dominant vendor providing the IP, maybe the aggregator provides the IP, him or herself, kind of limit the use case to something smaller and see if we can figure that out? DJ, did I get it?
Exactly. Yeah, Roberto, you got it. Exactly.
Okay.
That's the whole point, right? So we are not looking at a utopian solution right now. We are thinking of step one, and then that might simplify how known good die can be handled, because that might be only two-party interaction instead of multi-party interaction, as an example.
Okay. Yep.
Another thing I would suggest that might make this more bite-sized to figure out or solve is if we break this down into business. So you've got the SLAs, the interactions, the liability, those aspects. Then another category would be test. Where's the test industry going? What are the limits on test? What are we driving over there? And then the third being, integration. Um, rather than boiling the ocean of known good die, which has so many tentacles and impacts, business is one part, test is another part, and then the integration or the aggregation would be another part. Perhaps if we broke it in that way, we can identify areas that might be opportunities to build a more common ecosystem.
That's good feedback.
So, Roberto, maybe my suggestion is in the next meeting, you can, based on the feedback and discussion we are hearing, if we can just say this is how you see as a next step, and then and if needed, I can provide you if you want to meet with me or with Dharmesh or with any one of us. I don't want you to feel that you are the only one who's driving this. This is like today you got a lot of input, and then see how you want to structure it and what help you need from each one of us. And if that's something you can put together and share in the next meeting, because today was more around provoking discussion, and then how can we bound the problem. And I think we got some good inputs. Would that sound something reasonable or doable?
Yeah, I think so. And the one area I'd like to maybe get agreement with the team, and it's, if we maybe can try it over emails, what do we think would be, I think putting it in bite size is the right approach. Otherwise we'll just be locked in discussion for a really long time. So bite size is a good first step, but what do we think is a good deliverable? What would we all be happy with?
Yes, Roberto, along those lines, I had a question to Ravi. One of the bases, when we got Regan involved and Teradyne involved, was using the Mara test chip or the test vehicle, right? To look at this problem statement, how do you bring that chiplet into life or to life, right? So maybe we can go back to that and see, if you have to make Mara a real product, what are the different things that need to happen in terms of tests. And I think Mudarris's idea, is very apt here. Break this down from Teradyne's perspective. The test is their expertise, and they can look at what needs to be done in the test vertical to ensure that you get all the components of Mara to make that.
Swami, I really like.
Just a thought.
No, I really like the suggestion, and I think since Mara has been ODS and OCP test board in the past, and I think if we can, unless anyone has any objection, but I think we can take that as a test case or a use case for this thought exercise which we are trying to do, and see what do we uncover. And maybe within Mara we have like 4 or 5 different chiplet. Maybe we can do it like maybe limit up to 3 interaction. Like as we said earlier, let's solve it for what few vendor interaction and see how we can even do that thought exercise.
Yes, and Ravi, I think Rishi mentioned this. We really need to have I think Bill also mentioned, who's going to own this? Who's the integrator? Who's going to put this into effect? I think we keep coming back to that common basis. Is it a Broadcom? Is it a Xilinx? Is it an NVIDIA or an AMD? How are they approaching this? multiple chiplets. And as Elko also mentioned, in SIP we do multiple interaction, but the design is owned by one. It's very specific, right? It comes down to
Yes,
the
yes.
design, the IPs. So somebody's got to design this, and then you go about making the business model happen. Today, I think Anu mentioned the case of HBM. You're able to operate it independently. Many companies buy that, and then we integrate it, and that model is very prevalent today. So when it comes down to this, who's going to own this design? I think what Roberto can help us here is look at the test aspects of KGD. What are the different test mechanics that you can put in to ensure that you could reduce the scrap costs at the end of the day, and what are the different tricks that you can deploy wafer sort or at package test or at SLT. But beyond that, how do you affect this? We've got to think through that.
So Swami, and I agree, we don't know who that integrator is today. Maybe we can say, like, okay, assume it could be, like some of the names you mentioned, or maybe it could be one of the hyperscalers, right? And that we can start with that assumption and then see how the thought exercise will go.
Agreed.
Because I'm with you on that. We don't have any third party who's emerging as a chiplet integrator. So in absence of that, it could, the way I see is it could be a NVIDIA side of the world, Broadcom side of the world, or Facebook, Google, for that matter. Any of these, or Intel, AMD, any of these guys. But as long as we can say, if you have this something like a chiplet based product, and when you're thinking of known good die, how do you go about doing it?
Right. Yeah. So if you just take the example, right? I think this was brought up by Roberto. Ultimate integrator today, say for a phone board, I'm just bringing the biggest name out there, Foxconn, right? They make the biggest integrator, but do they own the system design? No. Do they, are they responsible for the liability of the entire, board? Absolutely not. The design is owned by one company that's going to sell the phone out there, right? Just taking a crude example of that. Of course, each individual sub-assembly integrator is responsible for their own quality and the yields, but the ultimate integrator is, he's not responsible. It is the person who designs that board, and the person who designs that board ensures that they have all the relevant contracts, all the relevant models, at what price are they going to procure all that, does it function to that required system requirement, how's the performance of the final board. So I guess you're absolutely right. We can we've got to play through that different role models, so to speak, and somebody's got to emerge as the owner of that. I think Bapi started that discussion on the email string, which Elko and myself contributed. So maybe that's one string that we can continue talking about that. I think Bapi, you mentioned that earlier in the 8 a.m. call. I don't know, Bapi's still on or he left.
Okay, I think in the interest of time, we have only 3 minutes left. So, does anyone have any objection using Mara, chiplet use case as a for this known good die, building this hypothetical thought exercise using Mara chiplet based product? So, should I treat silence as agreement?
Yeah, sure.
I have no objection. So Ravi, I have a simple question. Where do I get the information on that? Is that on the
I'll
ODSA
provide you.
website?
Roberto, I will send it to you some details.
Please, thank you.
Okay, we are out of time almost for the last topic, but I was thinking for OCP Tech Week we have to submit abstract on 23rd, and few things we can do. Either we can do like a general update, or we can do a two specific update, one on the known good die, which Mudassir and Harvey and Anu, and then maybe we can look into one maybe on the known good die or security. So there could be two updates coming from this work stream, or we can even organize one or two panel along those lines. Any thoughts, or do you guys want to have discussion through the email?
So Ravi, I think between Anu, Javi, and myself, we can definitely put something together as an abstract for the cost model.
So Mudassir, my question is, do you prefer a talk or you prefer a panel, or like have you thought like, what kind of format you want to do that?
No, I think we will need to discuss offline to decide
Okay.
on what format we would prefer.
Okay.
Yeah, I
Okay.
think we should get offline for that.
Yeah.
Sure. And Roberto, and I think maybe we can think of like some of the discussion we have, and and OCP Tech Week is in November, so we have time. And you may be wondering, the first call I am in, and here I've been asked to do something else as well. But I can work with you. But this is something maybe we can think of.
Yeah,
Yeah,
and
I know.
just
Yeah.
FYI, in terms of the timelines, actually timelines are pretty short for November Global Summit. We have to submit papers, abstracts, panels, workshops, ideas before 23rd July. So that's going to come pretty fast. And I think in next week or so, we should converge, or next 2 weeks, because we are not meeting. I guess we are meeting next. We won't be meeting for a couple of weeks. So we have to converge on what to submit very quickly.
Okay. So if anyone has any idea, please send me a note, and maybe what we can do is I will reach out to some of you individually and to discuss, what can we do. But please, if you have some ideas, please send it to me, or respond to the entire distribution. I'm fine with that. Okay. I want to be respectful for everyone's time. We are at the top of the hour. Thank you, everyone.
Thank you.